Hi students, hope you are all doing good. So today we are going to discuss the last session of nucleophilic addition reaction. Okay. So welcome to today's Brainiacs capsule. So I hope you could see the questions. So the first question here is arrange the following compounds in reactivity order towards nucleophilic addition reaction. Okay, so we need to identify from the three given compounds which is less reactive, then or maybe we can say increasing order of their reactivity or decreasing order of their reactivity. So from the options I can say they have arranged it in decreasing order of reactivity. So let's take these three compounds in detail. So the first compound is acetaldehyde. Okay, as you know earlier. So we have first step that is happening here is the carbonyl group will undergo polarization like this because oxygen has more electronegativity. So the pi bond will move towards oxygen atom and a positive charge will develop here and a negative charge will develop here. And we know that the octet of oxygen is complete here, correct? And who will come and attack first? Nucleophile. We know that nucleophile only will come and attack. Now the important question here is the rate of reaction depends upon how fast the nucleophile can attack the positive charge. So if the nucleophile needs to come to the positive charge means the magnitude of the positive charge here should be very high. Now if I am taking here, you know that this CH3 group, it has what effect? I can say it has plus psi effect. So because of the plus psi effect, what will happen? The electrons starts flowing in this direction. Okay, so what will happen? The magnitude of the positive charge decreases here, correct? Now if I am taking the second compound, you can see this is this is benzaldehyde. So here also if I see the first step will be polarization of pi bond towards oxygen atom, positive charge develops here. Now the most important thing you can notice here is the positive charge single bond, then there is pi bond, single bond, like that. So that means this positive charge can enter into resonance with the benzene ring. That means this positive charge is not available for most of the time here. So I can say that here the nucleophile will find it very difficult to find the positive charge and attack the positive charge. Okay, so I can say here the reactivity is very less. Okay, now we have finally the another compound. Okay, it is a derivative of imine. Okay, so in this particular compound, if you see here, you can see here also what is happening, sir. I can clearly say here nitrogen atom is present. We know that oxygen atom has more electronegativity, nitrogen has less electronegativity, so the polarization will not be even effective. So I can say that here the positive charge magnitude would be sufficiently less compared to carbonyl compounds. Okay, so what happens in addition to that, I can say there is a methyl group that is donating electrons to here because of the plus psi effect, and also you can see there is another methyl group located here that will also push its electron in such a way that there is a huge repulsion will happen. Okay, so altogether I can say its reactivity would be very less, or the nucleophile would find it very difficult to come and attack here because of the very less magnitude of the positive charge. So I can say on comparing these three structures, the very highly reactive one would be acetaldehyde, then comes benzaldehyde, second one, and finally your I can say imine derivative will come, correct? So my answer here would be which one, sir? One will be more reactive than second one will be more reactive than the third one. So I can say the answer for this particular question should be option 1 is my answer. Hope it is clear for you. Okay, now let's go to the next question. I hope all of you could see. Yeah, so the next question here is, listen, all of you please listen. Yeah, question here is the product formed by the reaction of an aldehyde with a primary amine is called. We already learned this in our previous Brainiacs daily capsule. So this is one request to all dear Neet aspirants. Those who have failed to watch our previous videos, you can go to our YouTube channel, find the playlist Brainiacs capsules. So there you can find each and important questions from every section of chemistry. Okay, so here we will see how we can do this question. So first of all, I am taking an aldehyde for you as an example. Okay, acetaldehyde itself I have taken. Then I have taken a primary amine. Why it is called a primary amine? Because of the presence of NH2 group. Now what is happening here? We know that in a carbonyl compound or aldehyde or a ketone, first step is always the polarization of carbonyl group like this. Because oxygen being more electronegative, pi bond polarizes like this, a positive charge develops here. Now we know that the octet of oxygen is complete here. So the first step will be nucleophile should come here to initiate the reaction. So from RNH2, first step would be what? Generation of nucleophile. So that H plus is removed and the remaining structure RNH minus here will behave like the nucleophile. Here will behave like the nucleophile. So what this nucleophile will do? Nucleophile will come and attack the positive charge like this, so that it will form a tetrahedral intermediate. Now in the next step, the removed H plus will attack the O minus and it forms a nucleophilic addition product. NAR product is this one. Okay, so we can say that the double bond has changed to single bond. Okay, and during the reaction nucleophile attacked first, so the entire reaction is nucleophilic addition reaction. But the problem here is, whenever I have told in my previous videos also, if you are seeing nitrogen compound attached to carbon and to that particular nitrogen, if hydrogen is present, what is the nature of that hydrogen? It can be acidic in nature. So what it will do? It will remove out as H plus. So what will happen? A negative charge will develop here. We know that negative charge developed on an electronegative atom is more stable. Okay, because electronegative atom loves negative charge. And the removed H plus will attack the lone pair present in the oxygen atom. So what will happen? You can easily see here oxygen loses the lone pair and a positive charge would be developed here. Because oxygen is also an electronegative atom, so if it is having a positive charge, it would be unstable. So what will happen? The pair of electrons near to this oxygen atom will move towards here or move towards oxygen atom. So the bond density would be like this. More electron density will be near oxygen atom and this will undergo breakage. So that what will happen? Water will be moved out like this and carbon will gain a positive charge. Now we know that negative charge, single bond, positive charge. So the negative charge will move towards the positive charge and it forms a pi bond. So you will get something that is called substituted imine because NH is there, that H is replaced here with R. So that's why it is called substituted imine. It is also known by a famous name. Substituted imines are also called Schiff's base. Schiff's base. Please remember this is mentioned in NCERT. Okay, so what is my answer, sir? All of you know what is happening now. So my answer here would be option 1 would be my correct answer. Clear? I hope it is clear for you. Now let's switch to the last question for the day. So here also we have one more question. I hope all of you could see it. Acetaldehyde react with semi-carbazide. The product will be, what is the product? So what is semi-carbazide? We will see that in detail. So I have taken acetaldehyde here. This is also a question related directly from NCERT. Okay. So how you get semi-carbazide? Very simple, sir. Take, I can say, hydrazine. Okay, this is hydrazine. Remove one hydrogen atom from the hydrazine. So you will get NH2NH. And in that particular NH, what you need to connect, sir? You need to connect a amide group, CONH2. Okay, so connect CONH2 to that, you will get semi-carbazide. Do you need another explanation? Very simple. One more time I am telling. Take hydrazine, NH2 single bond, NH2 is hydrazine. From that remove one hydrogen atom. So you will get NH2NH. Connect a amide group, CONH2 there. So you are getting semi-carbazide. Very simple. Again, the steps remains the same because you have the carbonyl group. So it will undergo polarization. Minus charge comes here, positive charge comes here. Octet of oxygen is complete. Octet of carbon is incomplete. You can see here 2, 4 and only 6 electrons are present near to the carbon. So what will happen, sir? First step should be attack from the nucleophile. So first step is removing H plus and you generate a nucleophile. So from this NH2, one H plus is removed. So you are getting a nucleophile like this. So this nucleophile is a bulky nucleophile which will attack the positive charge of the carbon. So what will happen? You will get a tetrahedral intermediate like this. You can see here. But steps are again the same. Then the H plus will come and attack here. So you will get your nucleophilic addition product. This is your nucleophilic addition product. But the problem here is, again you can see carbon is connected to a nitrogen atom, and that nitrogen atom again has a hydrogen atom. So I can easily say this is acidic in nature. So what will happen? H plus would be removed from here and a negative charge would come here to the nitrogen atom. You can see. Okay. So what will happen? When it comes like that, this H plus will attack the lone pair of the oxygen atom, and again as I explained, you can see here oxygen will gain positive charge. So the electrons in this bond will move towards oxygen and it will move out as water. So again positive charge comes in this particular one. So the negative charge will move towards the positive charge and you will get a semi-carbazide. Clear? Very simple. The steps are, I hope it is very clear for you. And this is called a semi-carbazone. The product is called a semi-carbazone. Okay. So I hope you could see that. So I can even little more I can move here and you can see the product, I hope. Okay. Yeah. So I hope it is very much clear for you today's session. So we will see with another concept that is very important concept called ozonolysis in the next days. Okay. Thank you.